Hello, good afternoon, everyone. I hope you can hear me well. And thanks today for the opportunity to be here to present for, in the frame of this conference. I am Antonio Caiazzo, working in the ESA ESTEC based in Netherlands for what we call the Clean Space Initiative, with the goal of finding or proposing ESA solution for a sustainable space sector. As probably has been already said before, I'm a system engineer here. It's been almost 4 years, together with a group of people, with a team, working on different topics within the Clean Space Initiative. And this is what I'm going to talk about now. Clean Space, basically, it's an initiative. It's an initiative that has as objective space debris mitigation, space debris remediation, and reduction of the environmental impact of future space mission. When we talk about space debris mitigation, the idea will be, and probably has been already mentioned also in the previous presentation, will be to mitigate the problem in the future. So to design future satellites in order to reduce the possibility of creating new debris. This goes inside Clean Space within the branch that we call management of end of life. Inside management of end of life, we have something like the program and projects for developing technologies like the orbiting technologies, like before I saw about drug sales, or the orbiting kit, in order to remove our satellite from the orbit within the 25 years space debris mitigation requirement. Inside this branch, this management of end of life, we also talk about design for demise. So try to design future satellite in order to ensure and to disintegrate the hardware, the space system, as much as possible during an atmospheric range. And in this way, in order to fulfill the on-ground casualty risk requirement, which is part of the space debris mitigation requirements. When we talk about space debris remediation, what we try to do, we try to remediate the issue we have today. We try basically to remove satellites from space, to remediate what has been done about debris environment today, currently. In this case, we move to the branch that we call in-orbit servicing, which includes also concept of active debris removal. And of course, inside this type of mission, inside this type of concept, we found interesting to develop technologies in different type of topics like Rendezvous, so technologies that will allow us to have a servicer satellite that is able to perform all the close proximity operation in order to approach a target satellite, a target debris possibly. In order to be able to perform rendezvous, capture, and then get rid of this debris through potentially an atmospheric range for debris that are in low Earth orbit. And in general, within the in-orbit servicing topic, we also consider services in the future that will allow to increase, let's say, the sustainability of space. We are talking about, for instance, maintenance in space, assembly, potentially manufacturing, or something that has been also mentioned in the previous presentation, something that we see really in the long term, possibility of on-orbit recycling. So possibility to reuse what is actually today in space, reuse all debris and try to recycle them, try to get from them parts that we can assemble on other satellites, or try to melt, let's say, old parts in order to derive and to manufacture new parts directly in orbit. This was a bit about space debris mitigation remediation. Moving to the third branch of Clean Space that we call Ecodesign. In this case, the goal is to reduce the environmental impact of space mission today, which also means reduce the effect of the atmosphere during an atmospheric re-entry or during a launch. In general, try also to apply what we call life cycle assessment. So try to assess the environmental impact of a space mission from different point of view, from different aspects, which go from the toxicity to the carbon dioxide production and so on, and try to assess those aspects in the different phases of the space mission. So from phase 0 to phase A to phase C, D until disposal, until the end. But we will go more in details during the presentation in all these 3 different branches. What has been actually mentioned, what has been claimed in the last few weeks, is this idea of ESA in the next, probably in the next decade, in the next years, of having net zero pollution emissions in the future. So the idea of ESA, the strategy of ESA, is to be able to design and to launch future satellites which are able to remove themselves from the orbit, which are able to clean the space in orbit by themselves, which means the orbital technology on board, which means capability to re-enter within the 25 years requirement, which also means design future satellite in order to facilitate debris removal mission, in order to facilitate from a servicer satellites the removal of the satellite itself. This policy, this strategy, it's actually called net zero pollution, which means every time we launch a satellite, we are able to remove it. So we are able to have a total of debris, of pollution, of non-functional satellites in orbit, which is basically zero. This is the idea. This is the strategy in the next years. And Clean Space is, of course, working on it in order to develop technologies which will allow in the future this net zero pollution strategy, which will allow in the future what the concept of space sustainability in general, which is the end goal of all the Clean Space initiative. Probably you have already seen this type of graph around in the literature review. What we know is that, of course, the number of satellites and as a consequence, also the number of non-functional objects in orbit is increasing. In particular, in the next 3 years, there will be more satellites launched than in the past 60 years. This is a consequence of the evolution of market, the evolution of the type of satellites, and of course, the implementation of concepts like mega constellation. I think you have seen and you have heard around Starlink, the concept of Starlink mega constellation or OneWeb and so on. This type of strategy, of course, will increase the number of satellites that we have in orbit. Therefore, it's important to have space debris mitigation requirements, which are enforced, which are commonly accepted, and which are followed by all the future actors in space in order to be sure that we can have sustainability of the orbit in the future. Probably you have also heard about recent collision, recent events that have generated many debris in space. Starting from the past, those are just some of them. In 1996, there was, for instance, this accident collision between a French satellite series and a part of an upper stage of the Ariane rocket. In 2007, there was the Chinese anti-satellite test. Also in that case, there were thousands and thousands of smaller debris that have been created in space because of this type of test. And something really recent that probably you have heard in the news, it was the anti-satellite test conducted by Russian. This was more or less, on the 15th of November. The satellite that has been broken in this case was Cosmos 1408. At the moment, there is still, of course, this event is still under investigation in order to better understand the consequences of this type of test. What we know now is that from these anti-satellite, from this test, more than 1,500 pieces have been generated. Potentially, all these debris have been generated in quite a low orbit, so in a quite low altitude, such that most of these debris, most of these pieces should re-enter in the atmosphere and should be not created a big problem in the orbit. Quite fast. So the re-entry of this type of pieces is expected to be quite fast. But as I said before, all the consequences of this type of event are still under investigation. Of course, this is something that we need to care about. This is something that we need to avoid in the future. And that's why we need to enforce what are today the space debris mitigation requirements. Space debris mitigation requirements that are covering different type of topics. From the need of removing from the protected regions our satellite, protected regions that are mainly today the LEO region and the GEO arc. The Clean Space initiative is mainly focusing on the LEO orbit, so on the low Earth orbits, and how to reduce the environment, the debris environment there. When we talk about removing from protected region, in this case, we are talking about the orbiting technologies. We are talking about the orbiting concept, which might be through uncontrolled re-entry, so a re-entry which does not need any type of propulsion system, or controlled re-entry in which we will use a propulsion system to target a specific area on ground. Among the space debris mitigation requirement, we also have the need to avoid in-orbit explosion. In-orbit explosion, which means avoid generating other debris in space. What we need to do in this case, our idea is to develop technologies in order to deplete any energy sources on board our spacecraft, which are mainly coming from the power subsystem or the propulsion subsystem. And that's why here you see that GliSpace is working on developing of technologies for power passivation or for propulsion passivation. So in order to deplete all the energy aboard and avoid in-orbit explosion. At the same time, other space debris mitigation requirements are about on-ground casualty risk. So when we have an atmospheric re-entry, we need to be sure that the on-ground casualty risk is limited. In particular, the probability of hitting someone is below this number 10 to minus 4. In order to be compliant with these type of requirements, we are developing technology in the frame of design for demise. I've seen before there was something about that. So we want to develop technologies, equipment, in general, all the space system, such that it's demisable. So it will disintegrate during an atmospheric re-entry as much as possible, and we will have a mission compliant with the 10 to minus 4 requirements. In parallel, we are also developing the orbiting system, which might be active deorbiting system. In this case, we are talking about potentially a propulsion system that will allow our satellites to deorbit faster, or passive deorbiting system, which was, for instance, the case of drag sail, in order to speed up the re-entry of the satellite. At the same time, in parallel, we are also trying to increase the reliability of our system in space. For instance, I will talk more about that. We are trying to develop design for removal technologies which are implemented on future satellites, with the goal of aiming at facilitating debris removal missions in the future. We will see that in the next slide. And in general, we want to create more reliable system, fail-safe system, so system that space assets that in case of failure in space, we are sure we can remove them, or we can consider the orbiting system such that we can get rid of the debris from the orbit. You can clean the space in general. So in particular, in the frame of end-of-life management that we also called clean technologies, we are focusing on 4 different technologies areas. The orbiting systems, probably it was also a topic in the previous presentation. So try to develop the orbiting system, which might be active or passive, in order to speed up the re-entry of our satellite from the orbit, in order to be compliant with the 25 years requirements, space debris mitigation requirements. Another technology area is the one regarding design for demise. So try to maximize the demise of the spacecraft during an atmospheric re-entry. Another technology area is about passivation, so try to passivate to deplete the energy sources on board our satellite. And of course, we want also to focus on successful disposal, so try to increase the reliability of future spacecraft during the disposal phase. About design for removal, what we are trying to develop here is technologies that we can implement on future satellites, like mechanical interface for capture, or retroreflectors or markers, in order to facilitate all the debris removal mission from a servicer point of view. So in order to facilitate the rendezvous, the capture, all the close proximity operation, and then the deorbiting of satellites that might fail in space in the future. We are talking about also, of course, grippers that can be implemented on future satellite and can facilitate the grabbing from a servicing satellite. Or we are talking about the tumbling technology, so technologies that will allow future debris to have a controlled tumbling motion, and this way to facilitate the close proximity operation from the point of view of a servicer satellite. I will go a bit faster. In general, we aim at design for removal technology which have a low system impact, so low accommodation, low mass, low interference with the rest of the system, and in general with the platform. An idea that we have in mind in this case is, of course, to together with the mitigation, also to have some other techniques. What we are trying to do, we are trying to upgrade future satellite platform, making them fully demisable, making them able to passivate the energy sources on board, and implementing, as I said, design for removal technologies to make easier debris removal. I see the time went really fast. I don't know if I have other couple of minutes, probably there are a few slides more. I don't know, Lucille, probably I will...
Yes, I think that's fine.
Okay. Then I will just take a few minutes more, probably to present something that might be quite interesting. What we have in mind to perform in particular by 2025 is the first active debris removal mission, which is called at the moment ADRIOS, or also another name that has been used in the past, Clear Space One mission. The idea here is to demonstrate that we have today the capability of removing a debris in orbit. In this case, the idea will be to develop a platform which is called Clear Space One, which will implement a capture system, and to remove one of the debris that we have in space today at an altitude, as you can see, around 800 kilometers. This debris is Vespa, is an upper stage of, it's part of an upper stage of the Vega launcher. The idea will be to launch our servicer, as I said, by 2025. Have all the try to demonstrate the capability of performing all the close proximity operations, so far range rendezvous, close range rendezvous, then capture with the target satellite, and then the capability of deorbiting this debris. This debris will be uncooperative, will be unprepared. So what we want to demonstrate is that we are developing, and we have by 2025 the technologies in order to perform active debris removal mission, and in the future in order to perform in-orbit servicing mission. So all the services that we were mentioning before, assembling, maintenance, and so on. This is what we are trying to develop now. So of course, capture system, for instance, the net, which is at the moment not the baseline of the future mission, but might be useful in the future. Try to develop gripper for capture. At the same time, try to develop technologies which goes on future client satellites, like interfaces technology, like standard interfaces. This is the case of ASIS that you see here, so interfaces for allowing refueling of the satellites in the future. And of course, what we are trying to do today is to test all these technologies inside robotic testing facilities that we have all over Europe, including ESTEC. At the same time, we need to develop technologies for Rendezvous, for in general guidance, navigation, and control aspects. We are talking about LiDAR technologies, image recognitions in order to perform what we call pose estimation of the target, and so on. Our idea is to be able to perform removal of the satellites in the future, but also servicing. The end goal will be to develop an ecosystem of service space, able to maintain future asset space, able to refuel, to assemble, to manufacturing. The concept we have in mind, which is at the moment really a long-term concept, and the end goal, of course, is the space sustainability, is to have this transition from what we have today, a culture of throw in space. Let's say we just send a satellite and then we did not care too much in the past. The idea will be, in this case, to have the transition from this type of culture to a circular economy culture, in which we are able to reuse our asset space, in which we are able to maximize the value of our space asset space, with servicer able to refuel, to assemble, to manufacture, with possibly orbital depots, which are fuel depots where our servicer can go, can refuel, and can then provide service of refuel to other satellites. Having, of course, an upgrade of future platform in LEO and GEO, able to be easily removed or easily maintained by a service satellite. What we think is that with this concept of circular economy, we can definitely be able then to ensure space sustainability. Through what we call in-orbit servicing. This is a bit the concept, and this is what we have in mind to do, of course, on orbit, so space debris mitigation, space debris remediation. At the same time, in parallel, we have to do something on Earth, on ground, which is reducing the environmental impact of space mission. This type of concept goes inside the branch of clean space that we call eco-design. Eco-design, basically, it's a concept that is aiming at developing what we call technologies that are able to minimize the environmental impact of manufacturing, during the overall mission, during the launch, and so on. This is something that comes from also one of the Sustainable Development Goals that has been, and one of the regulations that have been released in this case we have 2017, in order to make in general space mission more sustainable and more caring about Earth environment. What we are trying to do with eco-design, we are trying to develop these type of technologies. But first of all, we need also to assess the environmental impact of space mission. And this goes under the concept of LCA, so life cycle assessment, in which we need to be able to assess different type of parameters, what we call eco-indicators, that go from toxicity, so what is the impact in terms of toxicity of the space mission, what is the impact in terms of carbon footprint, biobased, and so on. And what we are trying to develop today is guidelines, is some, let me say, process in order to be able to assess, to apply LCA to space missions. In general, life cycle assessment, we call it's a multi-criteria assessment, because we have different criteria, toxicity, carbon footprint, and so on. But it's also a multi-step, because this type of assessment has to be done in the different phases of a space mission, different steps, from the design phases to the production, to the launch, to the use, and to the disposal of a space mission. I can go a bit fast. So the idea will be, of course, to develop what we call then, after we know we have an assessment, what we call green technologies, in order to reduce the impact of future satellites. And at the moment, there are several ESA projects ongoing. LCA and eco-design concept are applied on the future Ariane 6 launcher, on Earth Explorer satellites. Also, Copernicus is adopting this type of concept, this type of assessment, as well as the future Galileo system. In general, this is, let me say, the three main take-home messages. Minimize the production of space debris in the future to space debris mitigation technologies. And we were talking about design for demise, about the orbiting technology. Try to have also space debris mitigation in the future. So remove large item of debris. This is what we have in mind with the Clear Space 1 mission by 2025. But also after, after we have in mind to be able to do in-orbit servicing in order to ensure space sustainability in the future. And in parallel, we also need to reduce environmental impacts of space mission on Earth, which is something that Clear Space is trying to do with the development of green technologies through the eco-design activities. This is a bit the three main areas I wanted to mention today. I'm sorry if I went really over time, so I could not really go in details, but I hope, in case there is any question, to be able to answer and provide more detail afterwards.